This is a Follow Me coding video for Session 8, Implementing Classes. Please follow the video, pausing when I ask you to, and coding when I ask you to. If you haven't already done so, do VCS Update Project to get Session 8. Then open up the SRC folder and its M1R module. I'll let you come back to this, but I want to emphasize that you should read the code and make sure you understand why it prints what it does. If any of it is mysterious to you when it runs, please ask questions as needed. It's an important exercise. Now open up the M2 module. In this module, you'll implement a simple point class. It's not Rose Graphics, it's your own point class that you'll implement from scratch. Go ahead and do to-do 1, which is to put your name there, mark that to-do done, and then move ahead to to-do 2. If you fall behind at any point, simply pause the video and catch up. Keep firmly in mind that your goal is not to simply type in the code. The goal is to understand what you're doing. So take a look at to-do 2. It says that you're going to implement a class called point that has no methods yet, just the starting line, just a single line. Think briefly about what that single line is, looking at the to-do, and pause the video until you think you have it, then resume the video. To implement a function, you write def. To implement a class, you write class, C-L-A-S-S, followed by the name of the class, here point, followed by object in parentheses. That just means that this class extends the basic class, the most basic class called object. We typically put a short comment there, a doc string there, triply quoting it. Catch up on typing as needed, and then move on to to-do 3. Here's what happens if you run the program at this point. Nothing exciting. It just runs those test functions that are up there in main. None of them do anything yet. I'm going to take a moment and resize my screen so that it fits good. I encourage you to do the same, to maximize your screen, to get as much space off there to the right as you can. Notice the little thing to the left there that says project. That lets you get rid of that or bring it back, just as I just did. So I've now gone back to the beginning, done to-do 2, just typed in that class so I can mark to-do 2 as done, and then move ahead to to-do 3. To-do 3 gives the instructions for how you're going to do this exercise. We're going to do the beginning parts together, and then you'll continue this same pattern. In each method that you're about to implement, you're going to first read the specification of it. Here, the method called init, __init. So that's going to be up there. We'll do it in just a moment. Then you're going to look at the example code that will appear also there in the spec. Again, we'll do that in a moment for the init function. And you're going to scroll down. You're going to see that same example code that was up there in the spec. And you're going to go ahead and do some fancy keystrokes that we'll talk about in a moment to get it so that that code down there is uncommented. Then, having done that, you'll add one more test of your own. Finally, you'll go up there and actually implement the method here, the init method. That's just a quick summary of the process that you'll use for all the methods. Now we're going to go through the first several together. Here we're going to start by reading the spec of init. Recall that the __init___ method is the method that runs when you construct an instance of the class. So when you construct a point, init's going to run. We already know that when you construct a point, it takes an x and a y, and that's why there are two parameters, x and y. And what the method is to do is set the instance variables, the self.x and self.y, to those passed in values. Here's an example of code that calls init. You see that we're constructing a point at 3018. That construction causes init to run. It should set p1.x and p1.y to the 30 and 18 that are passed in as the x and y. So we expect to see 30 and 18 when we run this thing. Here's a second example where we make a second point, p2, at 100 minus 40. p1 should be unchanged, so p1 should still be 3018, and p2 should be the numbers that were written there. So remember our process. We start by reading the spec, then we look at the example. We've done those two. Now we come on down here to where that same code that we just looked at appears in the actual implementation of the test code in the test init. Now recall that they're up in main. It's going to call test functions for each of these methods that we're writing. When it's already been set to do that, but we don't want the bodies of the test functions to run yet because they contain code that would just crash until we actually implemented the method that they're testing. Here, for example, we're implementing the __init __ method. We've seen the spec, we've read the example. We're ready now to make the example code ready to run, but only now because we haven't written init, which we're about to do. Now there's a clever way to uncomment a whole bunch of code that already starts out commented, or to do the reverse. What you do, and you can do it right now, is you select all the code that you want to comment out, and then you hold down the control key, and while you're holding the control key, you press the / key, the one that is underneath the question mark. Again, select the items you want to comment out, hold down the control key, press the / key, the one that is under the question mark. You'll see that if they were all commented, they become uncommented, and vice versa. So go ahead and try pressing that key once, back, again, until you end up with all the code inside the run test init method being uncommented out, so it's ready to run, just like you see here. Pause the video as needed until you've got all the code in this run test init function uncommented, like you see here. So we've uncommented that code. The next step in our process is to add one more test of your own choosing, a test of your own choosing. It could be very simple. All it needs to do is, like the examples here, make a point and then print that point's x-coordinate. If the point is called p3, it would print p3.x and its y-coordinates. So go ahead and pause the video and do that now. All I did for my test is to change the coordinate, the y-coordinate of one of the points, and then the x-coordinate of one of the points, and then I printed to be sure that it changed like one would expect. So a better test would have been to make another point. Now, of course, running this test will do nothing. It'll just crash because we haven't yet written the init method. We haven't made code that makes p1.x and p1.y have values. That's what we're going to do next, is to actually do those. You can see off to the right what happened when I did attempt to run it. It said that point takes no arguments because so far we haven't made it do so. So go back up there to where we were defining the point class. You can make your thing go there, and for now just watch what I type, and I'll give you a chance to catch up here in a sec. Just watch what I type for now. We're defining the __init method, so I did a def with that. It wrote for me the self. Now remember that when you construct a point, you give it an x and a y, and that's why I'm typing in two more arguments here, x and y. And then I set self.x and self.y to x and y respectively. Recall that when init runs, self is set to the point being constructed, the object of the class being constructed. So this point gets as its x, self.x, it's passed in x, and self.y is passed in y. Meanwhile, I've gone ahead and run the init method, and you can see that it passed all its tests there. Go ahead and type in the code for that init method. Make sure you get 2 underscores there on each side of init, and run your code. Make sure it passes all the tests. While you're doing that, let me summarize what we've done so far. We started this project with main calling, I think it's 11 different run test functions that tests 11 different methods you're going to write. The first of those was the __init method that runs automatically when a point in this case is constructed, because we're doing the point class. We began by reading the spec for the init method down there in the run test code. Then we saw an example of it running, of the test running, creates a point. We check that the point has the coordinates it's supposed to after init runs. We uncommented the commented out code that was the same as the example we read in the docstring. We then added a test of our own, and then came back up to the definition of the class up top there, and added the definition of init that you are looking at now and tested it. Make sure that your init runs, that it passes the tests, and then continue with the video. So we're ready to move off to the next step. I'm just rearranging my windows a bit so that things can fit again. And we're going to go on down to, I think it's to do 4, where we'll do the next of our methods. So we've done to do 3, and then we're going to repeat the same process we just used, but now on to do 4. To do 4 is to implement what's called the repr method, the __repr method. Now, the spec for repr, which we're going to go up here and look for, is that it returns a string that represents the point. So we're going to return the string point, parenthesis, x coordinate, comma, y coordinate, close parenthesis. So repr runs automatically when print runs on the object. So this test case here makes a point, prints that point, P1, prints P1, and we expect point, parenthesis, 30, 18, because those are the coordinates of P1, to actually get printed. That's the goal. So we come down here, we look at these other tests here, we uncomment them like we've done before, and we're going to add our own test. To add our own test, just go ahead and change the coordinate of some one of our points here, and then we're just going to print the stuff we've been printing, and we're going to make sure that, in fact, when we print P1, it prints the coordinates of P1 with the right format, and when we print P2, it prints the coordinates of P2 with the right format. So I'm changing my expected values there to match those that I've just changed. Make a test similar to this if you haven't already, and then pause the video once you got your test, and then we're going to go back up together and implement it. While you're doing that, I'll comment that the test will fail at this point because we haven't written repr. Well, it doesn't quite fail. What it really does is print a strange notation that just gives the place in memory where that point is. So I'm going back up to the point class. I'm using, by the way, the little structure thing on the right there, the little to structure at the very bottom left. I'm using that. Now we're going to write repr. So watch what I do, and then I'll give you a chance to type. I've defined __repr__. That's just the special name of this function. It's going to return point, parenthesis, and then we're going to plug in the x coordinate and plug in the y coordinate. We write those squiggly brackets to do that when we use a method that's called format. So I'm applying the string method dot format, and the way dot format works is whatever I type here in the parentheses is going to get substituted for those squigglies. So here's where I'd like you to think. Go ahead and pause the video and decide what you put there to refer to the x coordinate and the y coordinate of this point. Pause the video and figure that out. Before I show you that, let's think it through. Remember, we're trying to take this point and do its x coordinate and its y coordinate. The only parameter in this method is self. So we've got to use self. It's the only thing. And when repr is run, self has been set by the system to the point that is being printed, the object of the class being defined, whose repr is running. That object, its string representation is going to run, and the data is of the object of that class, the point. So here, the way that we refer to this point x itself, this point itself, its x, is self.x. And this one's y is self.y. Here's the code, and then I'm going to go ahead and show you it run, and we'll see that it passes all its tests. That is, the expected part, what we expected, is the actual. Remember that what's happening in those tests is it's just printing the points we made, and we're confirming that it prints point, parenthesis, x coordinate, comma, y coordinate, close parenthesis. Here's that code again. Go ahead and make sure that you have it. So go ahead and type it in now if you haven't already. Run your code. Make sure it passed the test. Fix any typos you've made. The most common typo is to get the underscores wrong. Remember, this is defining underscore underscore repr, R-E-P-R, underscore underscore. It has to be spelled just like that, just as the init has to be spelled exactly right as well. That concludes the repr. So now we're going to go down to the next to-do, which is going to be for to-do 5. And in to-do 5, we'll see we're going to implement a method called clone. Now I want to emphasize we're now turning to clone. We're finished with the underscore methods. There will be no more underscores from here out. What clone does is it returns a new point whose x and y coordinates are the same as the x and y coordinates of this point, a clone, a copy. Now you already know how to make a new point. What do you type to make a point object? Think about what you type to make a dog object, and you'll be thinking about that. Here's the test cases. We made a point. We checked that it's x and y are 10 and 8 like we expected. We made a couple of clones, copies. We checked that they're going to be 10 and 8. So at this point, all three points, their x and y are 10 and 8. Then we change P1's x to 999. It should change to 999, but the others should not. And that's indeed what we'll see here. Then we're going to change P1's y, it looks like, and change to another point, P2, and then change P3's x and y. And again, these are copies of each other. Each one's its own point. So changing one of them isn't changing the others. So I've reflected that in the test cases there. And there we go. So once we get that right, we're going to go on down to the actual code for the run test clone. And then we're going to uncomment it and then go back and then add a test and then go back and do the actual code, and implement the actual code. Again, what we're just seeing here is that things are independent. P3, 777, 55, independently of P2 and P1. They started out all being the same values for their points, but they're clones, copies of each other. So I highlight all the code down here. I hold down the control key and press the slash key to uncomment it. Now pause the video while you write a test of your own. A test means that you're going to take a point, apply the clone method to it, and then write some prints that convince you that that clone is independent of the other points. Here's the test case that I chose. I made a clone of P2, one of the previous points, and called that new clone P3. Then I changed the y coordinate of P2 to a new value, which should not have any effect on P3, because P3 should be a copy. I then copied the print statements I'd used before and changed them appropriately to reflect the new things. That is, P2's x should change, so P1 should be unchanged. P3 should be the same as P2 was, which is 11 and 22 respectively. And then P2's x should change from 11 to 1. So here's P3, it should be 1122. And then P2's x, I've reassigned to be 1, so I'm going to change that in my expected value down there. I'm now going to go ahead and run the code, make sure it passes the test. I see, oh, of course it won't yet, because we have not yet implemented clone. So it just gives an error message. So I'm going to come up top there, and you should do the same. And now I'm going to define clone. Just watch what I do first, and then you can type. Clone, no underscores. Clone is a method that down there it's said is supposed to make a copy. So it has a single argument, self. Remember, self is the object being copied, the object in front of the dot. And so you know how to make a new point. You know how to return a new point. Just think about how you've been doing it all along. How do you construct a point? What do you type? And then that point's x and y should be the same x and the same y as this point itself. That's a hit. This point itself. Pause the video and figure out what goes right here. And then once you have a good thought, go ahead and resume the video. I hope you've remembered that to construct a dog, you type dog. To construct a point, you type point with a capital P. As to what goes inside the parentheses, it's to be this point's x, this point's y. The point itself is called self. So we want self's x and self's y. Self.x, self.y. I go ahead and run, test that I've got this right, and see that in fact it passes my test. So I go up there to the clone method and I check that my tests do pass. 10-8, 10-8, yep, 10-8s, yep, 99-8, and so forth. All my tests are as expected. The expected matches the actual. Go ahead and type up clone if you haven't already and run your test. Make sure it's just right. And then once you have everything right, go ahead and continue the video. Keep in mind that you cannot continue if you don't have a init right or repr right and now clone right. Then the rest won't work either. So get help if you need help to get this right, or watch the video more closely. So I mark to do 5 as done, and then I'm going to go on down to do 6 and get you started on that very last one. It's going to be the move to method, the move to, that was clone that we just did. Move to is going to take, in addition to self, an x and a y, and it's going to move the point to that x and that y. That is, it's going to change this point itself, change its x to the given x and its y to the given y. Here's an example. This one constructed points P1 and P2 at 10-8 and 50-20 respectively, and then it moved P1 to 5-1 and P2 to 0-0, so that when we print P1 and P2 in the code that just follows, it should print for P1 5-1, and it should print for P2 0-0. So that's our test case. Here's another test case where we change P2's y to 99, and that should change it to 99. And then we're also going to check that that move2 does not return a value, because it's not supposed to. It wasn't in the spec. So we take P2, call move2 on it, get the return value. That return value ought to be none. None with a capital N, because that's what methods or functions return by default if they have no explicit return. So if check no return is not none, we're going to print an error message there. That'll be our testing that it correctly did not return an explicit value. Just as we've done on previous to-dos, you're now going to go down to the implementation of the run test move to, uncomment the existing tests, and then add one of your own. Again, for your own test of move to, that means that you should take some point and apply move to it, and then print a result. I'm going to type in my example here. You can either follow along or type your own. Here's P, that is going to be a point at 2,5, and then I'm going to take and print that value of P just like I did before, and print that it's expected to be 2 and 5. So I'm going to change it there to 2 and 5. And I'll also print the actual value for P as well there. Then I'm going to take P and apply the move to method to it. So there it is, move to. And I'll give it a new point, x and y, that it's to move to. I'll move it to 50 and 33. And then I'm going to print that I expect now that it be indeed 50 and 33. And that'll be the end of my test. Go ahead and get that right for yourself, or this test or a different test, and then we'll move on up and implement the actual method. So here we are back at the top of the point class. Just watch what I type for a little bit here, and then I'll let you go. We're defining move to as usual. It takes self. This one, though, well, what does it take as arguments? Give some thought to that, pause the video, and then continue. The spec says that it should move the point to the given x and y. So we need to give an x and a y as arguments. Could have used any two names we want there, but x and y seem the natural choices. Now, what this function is to do, well, it's supposed to change something to something else. What should the something be, and what should the something else be if this is going to reassign this point's x to the given x, and this point's y to the given y? Think about that, pause the video, give it some thought, and then once you've decided on an answer, then, and only then, resume the video. So give it some thought. What I hope you've seen is that this points x means self.x. Remember that first argument, self, is set to the point that is being moved, the thing in front of the dot that is followed by move to. The argument could have been called x1 or x, doesn't matter. Whatever it's called, that's what goes on the right-hand side of this. So it's natural to just call it x. Self.x is being set to x. Self.y is being set to the given y. The thing on the left-hand side is the self, it's x, it's instance variable. The thing on the right-hand side is the parameter x and the parameter y. Once you have the code for move to correct, go ahead and run the program just like I'm doing here and confirm that you indeed passed your test just as I am here. Just confirm that the expected and the actuals are the same in all cases. I'm going to turn you loose for the remaining methods in just a sec. The next one you're going to do is the move by method. Move by a dx and a dy. It's very similar to move to, but move by. Here's an example where we set P1 to 10, 8, P2 to 50, 20, and then we move P1 by 5 minus 1. So it's going to move from 10 to 15. It moves by 5, and from 8 is the y-coordinate to 7 as it moves by minus 1. Likewise, P2 is going to move from 50 by 0, and it's from 20 by 0, so it'll stay at 50, 20. All right, we've implemented 4 methods. You're going to implement the remaining 7. Remember that for each of them, you follow the following process. You go down to the run test whatever method it is and read its spec. Then you examine the example in the spec. Once you're clear about what the method is supposed to do via the spec and its example, you scroll down to past the comment and uncomment the existing code there, which is the same as the example up above. And then you add your own test case to that so that you're clear about test cases. And then finally you go back up top to where the class is defined and add the code for the method you're working on and test to make sure it runs. Before you begin that, it's critical that you have your code working so far. So if anything isn't working at this point, if it's not the case that you've passed all the tests for init, repr, clone, and move to, if that's not the case, then if that's not the case, then you should stop working on the code and get some help before you continue. It's highly likely that you're going to have questions as you implement the following methods. So if at all possible, work during Live Now so that you can get instant answers to your questions. Almost all people will have questions working on this, especially when they get to the method get number of moves by. When they go to the method get number of moves. Let me give you a hint on that one. A point cannot return the number of moves it's made unless it has remembered that fact as it moves. So a little hint there. Bottom line, get help as needed as you work the remaining methods.